Hi everyone, we are going to talk about inheritance in Java in this video. Inheritance is hugely important. It's an important concept that goes with object-oriented programming, and we're going to see inheritance being used all the time in Android projects. And I realize some of you haven't gotten too far with it, so I'm going to kind of start from scratch here. I'm going to go ahead and I want you to follow along with me. So go ahead and let's create a new Java project, I should say. And we can just call it inheritance, or you can give it whatever name you want. There we go. And hopefully you've learned about packages in Java. The first thing we're going to do with this project is create a new package. So I'm going to right click on the source directory here and choose new package. Now the example that I'm going to be using is a car, so I'm going to name this package cars. Package names are all lowercase and no spaces or funny characters at all. So I'll go ahead and click finish here, and I'm going to create a class inside of this package. So I'm going to right click on the package and I'm going to choose new class here, and the class that I'm going to create is going to be a car. So we're going to be simulating cars in this example. So I'll just call it car, and remember that class names always start with a capital letter. That's how we can tell that it's a class as opposed to some other thing like a package, which is all underscores. So I'll go ahead and click finish here. And you should, let's see what we got. So we've got class car, and it's in our cars package here. So I'm going to go ahead and add a few instance variables right away. We're going to say that for the purposes of this app, we're going to keep track of a car's current speed and also its VIN number. A VIN number is kind of like a unique identifier for a car. So I'll go ahead and we'll make these private. And we'll set current speed equal to 0. Whoops. And we'll make we'll make VIN and int also, even though I suppose it could be a string. I don't know if real VIN numbers have letters in them or just numbers, but we'll just assume for this example that it's just numbers, and we'll call that VIN. And we'll just leave that uninitialized right now. And then the next thing that I'm going to do is we're going to create a constructor. We're going to overload the default constructor for this, so that when I use the constructor I can pass in the VIN number. So I'll go public car, and it's going to take a parameter called VIN. And then in the body of that constructor I will set this dot VIN equal to VIN, and I spelt VIN wrong up here. I said vid on the above line here, so I need to change that. Okay, so if any of this is unclear to you, we need to talk about it in class. But basically, by creating this constructor here, it allows me to create cars and give them an ID, a VIN number, at the time of creation. So, okay. So the next thing I'm going to do is add a method to this car class, and we'll make it a public method and have a void return type, so it doesn't return anything, and it's going to be called accelerate. So what that's going to do is that is going to increase the current speed of the car. So I'll just do this dot current speed plus equals 10. So I'm just kind of making this up. By the way, some programmers wouldn't like that I'm using just a hard-coded number right here. Sometimes we call these magic numbers, and we can have a discussion about that a little bit more in class. I don't want to get into it now, but since we're just messing around, I'll go ahead and use it. Some programmers think that this should be a variable instead of a hard-coded number 10, but Ask me about that in class if you want. All right, there is one more function or one more method that I want to create here, and I'm going to have to explain a little bit of this later, but what I want you to do is put this right here. We want to put this before our method. It's called an override annotation. Annotations in Java start with this @ sign, and I'm going to explain this a little bit later, but so underneath the override annotation, we're going to declare another method. It's going to be public. It's going to return a string, so that's the return type, and we're going to call it toString. Now, I'm not sure if any of you have worked with this before, but you'll see this a lot in Java code. And I'm getting the squiggly lines right now because I'm saying that it returns a string, but I'm not actually returning a string right now. Okay, so this toString method, what is it for? Usually programmers use the toString method to basically just dump out the state of an object. And what that means is it's just used to show what all the instance variables are set to, so that I could quickly see what the current speed of a car is and its VIN number. And a lot of times we use this for testing so that we can verify that the current speed and the VIN number are what we expect it to be. And we can just run the toString method just to confirm that everything's working the way we want it to. So a lot of times we use the toString method to simply just dump out all the instance variables related to an object. So what I'm going to do here is I'm going to return a string like this, and I'm going to concatenate labels and the values into the string. So I'll go VIN, and then I will concatenate the VIN number, this.VIN, and then I'm going to concatenate a label for the current speed. So I'll just call that speed here, and I'll concatenate this.current speed onto it here. Okay. Whoops, and I spelled return wrong, so I have to fix that. I'm going to save that, and now we're ready to test this car class out. What I'm going to do here is I'm going to, you know that in order to launch a Java app, at least one class in the app has to have a main method. I could put the main method right here in the car class, but a lot of times what we do is we create a special class that holds the main method. And I usually call those classes app driver. Some people call them main simply, but I usually just call them app driver. So I'm going to right click on the cars package here and do new class, and we'll call this app driver just like that, and let's let Eclipse put the main method stub in for us. So I'm going to check this box right here, and I'll choose finish. And now I'm going to go ahead and test out my car class that I just created. I'll get rid of this comment here, we don't need that, and I'm just going to create a new car object. So I'm going to put my cursor inside the body of the main method right here, and we'll get started. So we'll go car, and we'll just give it a name of C1 equals new car. And remember, I overloaded the constructor so that it so that we can give a car its VIN number as soon as we create it. So I'm just going to give it a VIN number of 111 right here. Okay. And then I'm going to call the accelerate method. So C1.accelerate, and then I'm just going to use my toString method here too. So I'll go system out, print line, and let's go C1.toString here. And let's see what that does. So if everything works properly, when we see the toString run, it should say 111, that's the car's VIN number, and then the current speed of the car should be 10, because remember, every time we invoke the accelerate method, which I spelt wrong here, I called it accelerate. Anyways, I don't know if you made that mistake or not. I sure did. I'm going to fix that right now. I'm going to pause it while I fix that. Okay, so I went back into the car class over here, and I added the missing letters, the EL here. And then I went back into app driver and I updated it here as well. So lots of typos, and typos can cause all sorts of problems. for programmers. Thankfully, the only reason I noticed that is because I had the squiggly lines underneath underneath it here, so the compiler was telling me that there was a problem. So I'll go ahead and save this and then run this app here. So I'll hit the run button, and you can see here that we called accelerate, and then we call our toString method, and toString returns a string, and that string gets directly passed right into system out print line. Okay, so sure enough, it looks like everything works the way we expect it to. It's got the VIN number that we set it to, and the speed is 10, which is exactly what we thought it was going to be. Now, this is a very simple class, and when you're learning, it's always great to use really simple concepts to figure stuff out so you don't get lost in all the complexities. But what I want to show you now is how we can use inheritance in Java. So like I said, this car class is very simple, easy to follow, but a lot of times we use inheritance. We inherit classes that are a lot more complicated than this. And the reason why is because it saves us from having to type a lot of code and figure out a lot of problems. Let me show you what I mean here. Let's go ahead and create a new class inside the cars package. So right click on the cars package and do new class, and I'm not really sure what to call this. I guess we'll call it enhanced car because we'll talk about this in a second here, but let's just go ahead and click finish. Okay, so what I want to do with this enhanced car class is I want to make cars that do all the things that our car class does. I want to have a VIN number, and I want my car to be able to accelerate, but I also want it to do other stuff. Now, I'm lazy and I don't want to have to rewrite all that code that we wrote in the car class. I want to use that code without having to duplicate it right inside of this class. So what I can do is, after the class name here, I can use this keyword, which is extends, and then here the name of the class that we want to extend. So what that means is that this enhanced car class is a car. So it's inheriting all the stuff that a car has. So there is one little problem right here. I need to fix this, and the reason is that I have to add a constructor that matches the constructor that we created in the car class. So I'm going to go ahead and do that right now. Actually, I'm going to let Eclipse do it. If I hover over the class name that has the squiggly lines on it, it's trying to suggest that there's a fix for the problem, and it's add a constructor. So I'll go ahead and click on that right there, and you can see what it does is it's creating a constructor for this class that takes a VIN number. Okay, and we'll talk about this in a second here. I'm going to go ahead and get rid of this comment. Okay, so what this is going to allow me to do is it's going to allow me to create enhanced cars and pass in a VIN number at the same time. So that was all the code that I had to add inside of this enhanced car, but I want to show you something here. I'm going to save it, so I'll do a control save, and I'm going to go back over to my app driver, and I'm going to go, I'm going to create an object of this enhanced car class. So I'm going to go enhanced car, and I guess I'll call it C3 or C2. I'm sorry. So this is going to be the second car object that we create, and it's then I'll use the constructor new enhanced car, and I will give it a VIN number. So I'll go 112 here. Okay, now watch this. Whoops, gotta put my semicolon in the right place. Now, this enhanced car, which we're calling C2, it is a car. It does all the things that a car does. So it is a car. So I can do this. I can go C2.accelerate, and then I'll system out print line the toString method again. C2 toString. Okay, and then if I save this and run it, you'll see that I've got a car with the VIN number of 112 and its speed is 10. Now, what I want you to note here is that I didn't have to define an accelerate method or a toString method inside of enhanced car. It inherited those methods and the properties, the VIN number and the current speed property, from the superclass. The superclass is the car. So you can see I'm going to go back over to the enhanced car class, and we see extends here, and then this is the class that we're extending. So we say that the car class is the superclass of this enhanced car. So you might be wondering, what's the use of all this at this point? But believe me, it comes in handy when you're dealing with complicated classes, and we're going to see it a lot in Android right off the bat. For example, let's just say my car class did something super complicated. Maybe it does something like tracks GPS coordinates or something like that. Something that takes a long time to figure out, and a lot of code and a lot of work to figure out how to do. Well, I can leverage that functionality in my enhanced car, because if there was a method in the car class that did something extremely complicated, remember that when I extend the car here, by doing extends car, I'll get all that functionality, all those crazy methods that would take me a long time to figure out how they work. That is the power of inheritance. Okay, now here's the other thing about inheritance. Not only can I leverage all the functionality that was built into the car class, I can actually add more stuff to it. So my car class doesn't account for any car colors, but you can't have a car that doesn't have a color, right? It's not invisible. So let's say that I want to add a color feature to this enhanced car. So all I have to do is simply add an instance variable for it. So I'll just make it public for now. And we'll just use it as a string, make it a string data type, like that. And now basically what I have here is a car that also accounts for color. So this class up here doesn't keep track of color, but all I had to do was extend that class and then add color to it, and now I can start setting and getting colors here. Let's say I want to improve this car even more than the superclass by doing another thing to it too here. Let's say I want, let's say that this car, when we call accelerate, it prints out to the console that it's accelerating. That's something that this car class, the regular car class, doesn't do, but we want our enhanced car to do. So what I can do here is I can redefine that accelerate class. So whenever you do that, whenever you redefine a method that's in the superclass, that's when you use this override annotation. So I'm going to go like this, and it was a public void method called accelerate, and let's say let's see here. So the car class actually does the acceleration for us, but we want to show what the current speed is every time accelerate gets called. So what I want to do is I want to use the code that's in the superclass's version of accelerate. So what I can do is I can type super.accelerate, and what's that going to do? That will do that will bump up the current speed of the car to 10, or by an increment of 10. Okay, so now by doing this, this will actually bump up the current speed by 10, and that code is in the superclass, and that's why we use super.accelerate. So that says go to the superclass and call the accelerate method. And then on top of that, I also want to output a message saying that we're accelerating. So I'll do a system sysout print line here. and I'm just going to concatenate this dot current speed. Look at that. The problem I'm having here is it won't let me do current speed here. And does anybody know why that is? It's because current speed is set to private. So remember that private instance variables can only be accessed through the class itself. So the current speed instance variable is declared inside of car, and it's set to private here. And so it can't be accessed from any other class. And now I'm in a different class here, and when I type in this dot current speed, it's saying that it doesn't recognize it because it's private in the superclass. So to get around this, I could create getters for current speed here. I don't want to get too bogged down. I don't want, but anyways, just to work around this real quickly here, I'm going to set this to public. I shouldn't really do this because they say it's bad practice to make public instance variables. You should make them all private and then use setters and getters to access them. But just for the purposes of messing around here, I'm going to make it public. So I'll save that. And then over here, you'll see that that error goes away. All right, so I'm going to go ahead and save this. And now go back to my app driver. And I'm going to run this again. I'm not going to make any changes here. I'm just going to rerun it. So what we should see here is when we get to line 13, at least it's line 13 for me, when this enhanced car, which has a name of C2, has accelerate call, it should print something out to the console. So let's see what happens here. There we go, and there it is. So what we can see here is that what we did here is we overrode the superclass's version of accelerate. So, and when you do that, because the car class has an accelerate method in it, and when you want to override the superclass's version of this method, you have to use this annotation here. So that's why we put that there. And now I want to override the superclass's accelerate method by adding to it, but I also want to use the superclass's method, because remember, inside the superclass, that's where the code is that actually increments the current speed. So right here, by doing super.accelerate, that's going to actually increment the current speed of the car, and then I'm enhancing this method by just printing out a message of what we're accelerating to. Okay. Now I want to come back to something that we did earlier. I didn't really explain what's going on here, but it's really similar to what we just talked about. So when Eclipse put in this code for us, remember we had Eclipse write this code for us, we didn't write it ourselves. It's calling super and passing in the VIN number. Now if there is no dot method name after super, then it's implied that what's happening is you're calling the superclass's constructor. So let's just take a look at the superclass's constructor again. So we'll go back over to car, and we'll see that the code inside the constructor takes the parameter that gets passed in, and it sets our instance variable. So if I were to comment out this line of code right here, then our car wouldn't actually get a VIN number, because this parameter that gets passed in would actually be lost because we're not doing anything with it. But because I'm actually calling the superclass's version of the constructor, which is right here for me on line 8, the code inside of that constructor actually sets the instance variable to this parameter. Okay, so there's another variation of how the super keyword is used in Java. Okay, I try to keep these videos to 20 minutes or less. We're going to go over a little bit on this, but I do want to show you one more thing here. I'm going to do one more thing with my enhanced car class. So I'm going to actually override that toString method. So remember, when we override a method of the superclass, we have to use the annotation, the override annotation. So I'm going to type in override, and it's a public method, and it returns a string data type, and the method name is toString. It takes no parameters, Right, set it up just like this. And now, like I said, we use this toString method to dump out the state of the car. So what have I done to this enhanced car that's different than its superclass, the car class? I added a color to it. So now when we call toString, we not only want to see the VIN number and the current speed, but we also want to see the color that the car is set to. Now let's do this. I'm going to go super dot. Here, let me back that up here. I'm going to type return and then super dot toString like that, and then by calling, let me get rid of those boxes there. By calling super.toString, that's going to return a string that has the VIN number and the current speed of the car. So that's what we're going to get from this method call right here. That's what's in the superclass's toString method. And we're going to add on to that. We're going to add the color here. So I'm going to concatenate a label for the color and this dot color. Okay, so once again, we're leveraging the code that's already been written in the superclass, in the car class. We don't have to rewrite that code there. It's gonna, by doing this super.toString right here, it's going to give us a string that has the VIN number and the current speed on it, and then we're just adding onto that string color and it's a label for color. So let's see what happens here when I save this. And I'm going to go back over to our app driver, and I'm just going to run it again. We'll see what happens here. Now look at that, color showing up as null. That's because we never set it anywhere. So let me just go ahead and before we call the toString method, let's set c2.color equals red. And then I'll run it again here, and you can see that the color is getting dumped out as well too. Alright, now this is a trivial example. I think it might be hard to understand the power of inheritance just by these trivial examples, but we're going to take a look at Android, and you're going to see right off the bat that we're going to be using inheritance all over the place. So it's a concept that you have to get familiar with. Alright, that's all for now.